Welcome to solverfy.
In this problem, we have been given the information about the movement of car. So before that, let's consider this as the north direction, south, east, and the west. So in the problem, we have been given that the car is able to move at an angle which is along the west direction, that's 215 kilometers. So car moves absolutely along west direction by 215 kilometers, and then further the car moves 85 kilometers southwest. So the southwest is in this direction, that's making an angle 45 degree with respect to the west and the south direction. So car moves parallel to this direction by 85 kilometers. So we need to determine here the displacement of car with respect to the origin. So for that, first we can assume that the initial vector was vector A, and we can write that as minus 215 I cap. So I cap is indicating the direction along the negative x-axis here. And then further we need to break down this 85 kilometer vector along x and the y direction. So along x direction, we will see the component is 85 cos 45 degree, and along negative y direction, it would be 85 sine 45 degree. So when we figure out the value of each one of them, we get the component as 60 minus 60 I cap minus 60 j cap approximately for B vector representing the motion after going through the west direction. So now in order to get the resultant displacement, we just add these two vectors, vector A and vector B. So this comes out to be minus 275 I cap minus 60 j cap. So this is the resultant vector of the car, and in order to get the magnitude, we get the magnitude as root of 275 square plus 60 square. So when we square the value of 275 and we add here the square of 60 and we take the complete root of this, we get 281.5 kilometers. Now this is the overall magnitude of the displacement vector of the car with respect to the origin O. And yes, we can get the direction of this displacement vector as well. So to get the direction, we take the y component of displacement and divide by the x component, and we take the complete tan inverse of that. So when we divide 60 by 275 and take the tan inverse of this, we get the angle here as 12.31 degree. Now this 12.31 degree, if we observe the displacement vector, both the components are along the negative direction, indicating that the displacement vector would be somewhere over here. And we have figured out this angle theta. So we can say that the displacement vector is at an angle 12.31 degree with respect to east direction.